All right, welcome to the Explainer. Today we're going to talk about a chemical I'm sure you've heard of, serotonin. But its story is probably a lot different than you think. Now, most of us probably know it as the happy chemical, right? But is that really the whole story? Is happiness its only job? Let's dig in. Well, the truth is, what serotonin actually does in our brains is way more complex and, honestly, a lot more fascinating than just making us happy. Okay, so first things first, let's just tackle this happy chemical myth head on. And get this is going to blow your mind. Only about 5% of your body's serotonin is actually in your brain. Yeah, you heard that right. The other 95%, it's hanging out in your peripheral nervous system, mostly in your gut. And here's the kicker. The serotonin in your gut can't get into your brain. They're two totally separate systems. So the stuff in your stomach has nothing to do with the stuff affecting your mood. So you might be thinking, if there's so little of it in the brain, how can it be that important? Well, it's not about how much there is. It's about what it can do, its reach. And this image, wow, it just shows it perfectly. See that small red area in the brainstem? That's where the serotonin neurons start. But look at how they spread out, like this incredible web, touching almost every single part of the brain. That tiny 5% is acting like a master modulator, kind of like a conductor for a massive orchestra. And its influence is just huge. We're not just talking about mood. It's fine-tuning almost everything. How you think, your memory, when you sleep and wake up, your appetite, anxiety, even how you perceive the world around you. It has a hand in pretty much every key function. Okay, so how on earth can one little chemical do so many different jobs? This is where the whole system gets really, really cool. The secret isn't actually in the serotonin itself. It's in how the brain listens to it. Think about it like this. If serotonin is a master key, then your brain is just filled with all these different locks. We call them receptors. The same key opens all of them. But what happens when you turn that key? Well, that totally depends on which door you just unlocked. And we're not talking about just one or two types of locks. Scientists have found at least 7 families of these serotonin receptors and a whole bunch of subtypes within those. So, for example, you have the 5-HT1A receptor. That one is mostly about mood and anxiety. Then there's the 5-HT2A receptor, which plays a big role in perception and how you think. And then you have something like the 5-HT4 receptor, which helps you learn. See, it's the same key, serotonin, but depending on which lock it opens, it can do anything from helping you remember something to calming you down. So, what happens when this incredibly complex, finely tuned system gets out of whack? You know, when the conductor starts to lose the rhythm? Well, as you can probably guess, when this master modulation system has problems, it's linked to a whole range of neuropsychiatric conditions. The ripples can spread out and affect so many different parts of our mental health. The one we've all heard about, of course, is depression. The classic idea, the serotonin hypothesis, is that when this system is underactive, it can lead to depressive symptoms. It's like the conductor for your mood is just leading the orchestra a little too slowly, a little too quietly. Anxiety is also super closely tied to this. Since serotonin helps manage our fear responses, if that system is off, it might be sending threat signals that are way too strong, or sending them at the wrong time. And that can create this constant state of anxiety. And then with OCD, researchers have found really specific problems with the machinery that actually transports and receives serotonin. So it's not just about the amount of serotonin, it's that the equipment itself is faulty. When the systems that are supposed to control repetitive thoughts aren't working right, you get stuck in those OCD cycles. You know, even in something as complex as schizophrenia, serotonin dysregulation is a huge piece of the puzzle. It shows you just how connected everything is. When serotonin's ability to modulate our perception is off-key, it can mess up the entire performance, even the parts being led by other chemicals, like dopamine. So all of this complexity, it really explains why treating these conditions isn't as simple as, oh, let's just boost serotonin. The system is just way too sophisticated for a simple fix like that. You've probably heard of SSRIs, right? They're a common type of medication designed to increase the amount of serotonin that's available between your brain cells. Basically, they stop it from being reabsorbed too quickly, so there's more of it floating around to do its job. But, and this is so important, these drugs don't work overnight. If it were just a matter of having low serotonin, they should, right? The fact that they can take 4 to 6 weeks to really kick in tells us something huge.
It tells us the brain is using that time to actually adapt and rewire itself. It's not about a quick chemical fix. It's about long-term changes, what we call brain plasticity.
So now we can really see the difference. The myth is low serotonin causes depression, but the reality? The reality is that it's about dysregulation across this incredibly complex system, with all its different receptors and pathways, and that's linked to a whole range of conditions. Serotonin isn't just a happy chemical. It is a master modulator of your brain. And, understanding this complexity moves us away from these one-size-fits-all solutions. It points us toward a future of much more targeted, much more nuanced therapies, a future that really respects how incredibly complex our brains are. And that leaves us with one final thought. If our brain is an orchestra, how can we become better conductors?